Graphing rational functions. So we have fractions, rational expressions, right? They have denominators. But what types of numbers can our denominator not be? Or what number?
Zero.
Zero. We can't have a zero in the denominator. Why? Yeah, we can't divide anything by zero. So graphing rational functions, we get breaks in continuity, like vertical asymptotes and holes, if we have a zero in the denominator. So we need to know what a vertical asymptote and a hole is. Vertical asymptote. It is a vertical dashed line. It's called an asymptote because the graph is going to get very close to it, but it's never going to touch it and it's never going to cross it. Our graphs are going to look something like this. Okay, that's a rough sketch of what a rational function looks like. Okay, so this vertical asymptote here, notice that we have the end of the graph is going down towards it, but it's not actually going to cross it or touch it. And the left-hand side, the graph is going up. It's not actually going to cross it or touch it. So that's a vertical asymptote. Okay, a hole is like that. There's just a hole. There's a break in the line. It really is just a hole in the line. So that's a hole. Okay, so we have vertical asymptotes and we have holes. Now they both happen because we get a zero in the denominator. But there's going to be two different ways how we can get a zero in the denominator, and then based off which way is whether or not we have a vertical asymptote or a hole. So we're going to start with vertical asymptotes. So these happen when our denominator is 0. So like f of x is equal to 1 over x. Let's say I give you this function. Okay, that's a rational expression. What would make this denominator 0? So what would make x 0 if x is equal to 0? So there would be a vertical asymptote here at x equals 0. So on our graph at x equals 0, we'd have a dashed line, vertical dashed line at 0, and the graph, that would split the graph up into its two separate parts. Okay. What if I change this up a little bit, and instead I said f of x is equal to 1 over, I don't know, x plus 2. Now what would make the denominator 0? If x were negative 2. So here we'd have a vertical asymptote of x equals negative 2. Okay, so that's how vertical asymptotes occur. Is that okay? Now, holes are going to occur when you have to factor it. So when we factor the numerator and the denominator and we have something cancel. Okay, holes are going to happen wherever that value cancels. So for example, if I have f of x is equal to x plus 1 over x plus 2 times x plus 1. Okay, so it's already factored out. This is our function. And so when you factor it out and you look, you go, okay, does anything cancel? The x plus 1's, these cancel. So because these cancel, that's where our hole is going to be. So this would tell us we have a hole at what value would make x plus 1 0? What value would make x plus 1 equal to 0? Yeah, so the hole would happen at x equals negative 1. So do you guys understand the difference between what makes a vertical asymptote and what makes a hole? You don't need to worry about how to graph them quite yet. I just want to know that you get the difference between what each one are.
What symbol is that?
I just did an at symbol instead of writing out the word at.
Both of them you want to make 0?
Yep, both of them you want to make it 0.
So then what's the difference?
The difference here is when it cancels, it just gives us a hole. When nothing cancels with it, it's a vertical asymptote.
Is that an x plus 2?
Yeah.
So how do we get x plus 1?
I gave you this formula. I gave you the whole function ahead of time. Yeah. I gave you this whole function. So x plus 1 over x plus 2 times x plus 1. I gave that all to you. So the x plus 1s would cancel, meaning that would give us a whole where that equals 0.
So then the x plus 2 just isn't
That just gets to stay there in the equation. Okay? So let's try some examples where that's exactly what we're doing. I'm going to give you a function. We're going to decide if we have vertical asymptotes or holes. Okay. Okay. So we're going to have to factor. We're going to have to factor. So number 1, f of x is equal to x squared minus 1 over x squared minus 6x plus 5. Well, you've seen rational functions like this, and you guys have factored ones like this before in this unit. Okay, so we just have to factor it. So let's start there. So x squared minus 1, how does that factor? Yep, x plus 1, x minus 1. Over x squared minus 6x plus 5. How does that one factor? So x minus 1, x minus 5. Okay, so the first one we look for is we see if anything will cancel. Okay, so the x minus 1s, these cancel. So because they cancel, it tells us there's a hole. So here there's a hole at what value makes x minus 1 0? 1. So there's a hole at x equals 1. Okay, so let's look. Do we have anything left in the denominator? Yeah, we still have this x minus 5 left here. And nothing will cancel with this, so that means that this is a vertical asymptote. So here we have a vertical asymptote. We just abbreviate it VA. What value makes x minus 5 0? So the vertical asymptote is at x equals 5.
Why can't we use x plus 1 again?
Because that's in the numerator. Anything in the numerator just gets to stay there unless it cancels.
So for the whole, you want to make the numerator 0.
You want to make whatever you canceled 0. So we canceled the x minus 1, so we made that 0 to get our whole at x equals 1. Okay? Is that one okay? All right. Let's look at the second one. F of x is equal to 3 over x squared minus 4x plus 4. All right, why do we know there wouldn't be a hole right away? Yeah, there's nothing to cancel with in the numerator. Still need to factor this denominator, though. How do you factor x squared minus 4x plus 4? Yep, x minus 2, x minus 2. So we already said there were no holes. Vertical asymptotes. What'll make this denominator 0? 2. So the vertical asymptote is at x equals 2. Is that okay? We'll do 2 more of these and then we'll graph. So number 3, f of x is equal to x minus 1 over x plus 5 times x minus 1. Yep. So this one's already factored for us, which is nice. So we just cancel the x minus 1s. So that tells us our whole is at 1. So x equals 1. So we just made x minus 1 equal to 0. And the vertical asymptote, where would that be? Yep, x equals negative 5. Is that okay?
Is there usually always going to be both of them?
There will always be one or the other, or maybe both. When you're graphing them yourself, though, there will never be both of them in the same graph.
How do you know?
So if the numerator was just, there's no x in the numerator,
You'd only have vertical asymptotes if there is not an x in the numerator to be canceled with.
Is it always going to be x equals 1? Unless there's multiple cancels?
For the whole, you mean?
A whole, yeah.
Yeah, the whole will only happen if it cancels. So if only one thing cancels, you're only going to have one whole. mean, you could have more, but I'm not going to give you ones with more. All right, so let's do one more of this, and then we'll graph. F of x is equal to x squared minus 4 over x squared plus 5x plus 6. So we're going to have to factor. X squared minus 4, how does that factor? Yep, x minus 2x plus 2. X squared plus 5x plus 6. Yep, x plus 2x plus 3. Okay, anything cancel? The x plus 2's cancel. So since they cancel, what does that tell us? Yep, the whole is at x equals negative 2. Do we have anything left in the denominator? Yeah, what do we have left? X plus 3, so that tells us our vertical asymptote is where? At x equals negative 3.
So if the numerator cancels out, the denominator cancels out the numerator, and that's the only thing in the denominator?
Then we wouldn't have any vertical asymptotes, that's right.
Why is our whole negative 2 now?
The whole's at negative 2 because x plus 2 is canceled.
Yeah.
Well, what makes x plus 2 0?
2.
Negative 2 would make x plus 2 0.
Oh.
So you're just solving that equation for 0.
Wait, so you just ignore the other top in the numerator?
Yes, you just ignore the x minus 2 in the numerator. If the numerator wasn't canceled, it's going to have nothing to do with it. Okay, we're ready to try graphing one of these? Okay. Graph it. F of x is equal to x over x plus 1. Okay, so when we go to graph these, we want to decide first off if we have vertical asymptotes or holes. Okay. Okay, so here we have a vertical asymptote. Where will it be? So that's our vertical asymptote, which means we have a dashed vertical line at negative 1. So on our graph, we are going to draw in a dashed vertical line at x equals negative 1. Okay? That split our graph into two sections. Okay? So what we're going to do now is we are going to make two separate xy charts. We're going to make one xy chart for the right-hand side of this graph, and we're going to make one xy chart for the left-hand side. Because each side of this graph is going to behave differently. So here we have the right side. Make an xy chart, and we will do the same thing for the left. So now, these rational expressions are going to get close to this asymptote. We don't know if it's going to be close up here or close down there, though. So what we need to do is we need to pick a few points very close to the asymptote, so in between negative 1 and 0. Now, if you're not good at fractions, that's fine. You can pick decimals. I'm going to pick fractions. Okay? So a fraction that's close to negative 1, but still on the right-hand side, would be like negative 3/4. Okay? And then a little bit further away would be like negative 1/2. Right here is our vertical asymptote. So we're comparing to this negative 1 here. So we want to go pretty close to it. So I'm saying negative 3/4 is pretty close. Negative 1/2 is a little bit further away. And then let's go over to 0. Okay, so there we have a few points that are close to this vertical asymptote. Now let's do a point that's far away from it so we kind of know where it's going at this end. So on my graph, 7's the furthest away, so I'm also going to plug 7 in. Now I'm going to strongly recommend that you use a calculator for this. And I want you to do this with me because I know some of you are going to make some errors on plugging this into your calculator. Okay, so plug negative 3/4 in to your function x over x plus 1 and figure out what you get for your y. So plug your negative 3/4 in for your function to figure out what you get for your y value. Negative 3 is correct. Now, a lot of you got 2, so let's talk about why you got 2. So you guys, in your calculator, you typed in negative 3/4, and then you hit the divide by button. You typed in negative 3/4 again. That gave you 1, and then it added 1. So that wasn't quite right. So when you're putting it into your calculator, make sure that you take negative 3/4 and you divide by, in parentheses, the negative 3/4 plus 1.
So you just have to
Add parentheses in there. Okay, make sure you're dividing by that whole x plus 1. So try that again and make sure you get negative 3 this time now.
Yeah, I got it.
You got negative 3 this time?
We're gonna get it.
Okay, so now let's plug in negative 1 and see what you get.
Negative 1.
I'm sorry, negative 1/2 and see what you get. Yeah, you get negative 1. Okay, plug in 0. What do you get? Think about it. 0. Why do you get 0 when you plug 0 in? There's a 0 on the top. Okay, and now plug 7 in. 7/8. Now once again, if you are not good at fractions, if you're not good at seeing where these fractions are, that's fine. Use decimals in your XY chart. So use like negative 0.8, negative 0.5. Okay, your values don't have to be the same as mine. You're still going to get an accurate graph. Okay, so now we will plot these. So negative 3/4. So we're pretty close to the line, and we're down at negative 3. So we're going to put a point there. Negative 1/2. We're down at negative 1, so we'll put a point there. And these are approximate because they are fractions or decimals. 0, 0, we know that one for sure. And then 7, 7/8. What can you tell me about 7/8? Is it still under 1 or is it over 1? It's still under 1, so we're just going to put that right underneath that 1 there. So now when we go to graph this, we don't want to cross this vertical asymptote. So we're going to start down here. We're going to start close to it. We're going to go up and we're going to get our points. We're going to see we're curving a little bit and go out to go through your 7/8 point there. Is that okay? All right, so let's look at the left-hand side. So the left-hand side, we need to pick some points that are very close to it. Okay, so here's our vertical asymptote at negative 1. So what's a point that's close to this on the left-hand side?
1 1/4.
Good, it's a negative 1 1/4. What's a point that's a little bit further away from it then? Yeah, negative 1 1/2. Then we could probably do negative 2. And then on my graph, negative 7 is the furthest out. So, and once again, you can use decimals. So you could start with here like negative 1.2, and then negative 1.5. That's fine.
Do you want us
Yes.
to do only 4 different points?
Yeah, 4 should be fine. You can do more if you're not sure what the graph looks like. You can do, 4 is probably about the minimum you should have for each section.
Why are we using like halves and fours?
Because we need to see what this graph is doing close to the vertical asymptote. So here, as we got close to the vertical asymptote, we saw that it was going downwards. If we didn't have those 2 points here, we would not have known what was going on.
So could we use the same thing as we use like these negative 3/4? Could we use negative 3/4 something like that?
No, we couldn't use negative 3/4, or no, because that's not over. We couldn't use positive 3/4 because that's not on the left-hand side of the graph. So you have to look at where your vertical asymptote is and go to the left-hand side and pick those points. Okay. Like I said, you can use decimals if you're more comfortable using decimals. That's perfectly fine. So what do you get when you take negative 1/4 and you plug it in? 5. What do you get when you take negative 1/2 and plug it in? 3. What do you get when you take negative 2 and plug it in? 2. And what do you take when you get, what do you get when you take negative 7 and plug it in? 7, 6, or 1.1 something you got? Okay, so now we're going to graph these. So negative 1 1/4, so we're close to the line, and we're up at 5. So about right there. Negative 1 1/2 and 3. So about there. Negative 2, positive 2. And then over at negative 7, 7, 6 is just above 1, so we're going to keep that value just above the 1. And then from those points, we see we're really close to the vertical asymptote here. And so we'll go down. You see it curves a little, and we go out to hit that line. So there's our rational function. Is that okay? So that's one with a vertical asymptote. We should probably look at one with a hole as well. Can I go to the example? Yeah? Okay. So here's the next one up will be the whole one. So here, f of x is equal to x squared minus 4 over x minus 2. So first we want to see if we can simplify it down. So how can we factor x squared minus 4? Yep, x plus 2, x minus 2 over x minus 2. So the x minus 2 cancels, so that tells me we have a whole at x equals 2. And since they canceled, what's our function that we have left that's simplified? Yeah, just x plus 2. Now, this is actually a very simple graph to graph. You've been graphing these for a very long time. Instead of writing this as f of x is equal to x plus 2, what if instead I said y equals x plus 2? Do you know how to graph it now? Some of you may need this hint in there, mx plus b. Now, does everyone know how to graph this? Where's your y-intercept? 2. Your y-intercept is 2. Then what's your slope? Up 1 over 1. Okay, well, we need to take into consideration our whole. So here I plotted points where my graph should be. And now the whole is at x equals 2. So on our graph, x equals 2 is right here. So you have to go up and find your graph and just put a hole there. Your y-intercept was 2, so we started at 2. And then our slope was 1, so we went up 1 over 1, up 1 over 1. Okay, and then once again, the whole is at 2. So we go to x equals 2. We go up and find our graph. And we just draw a hole around that point. And then we can connect the other dots in a straight line. And that's our graph. Is that okay?
Is there no VA?
Yeah, there's no vertical asymptote here because the denominator completely canceled and there was nothing left.
So if there is a vertical asymptote,
Then I would not give you one to graph that has a vertical asymptote and a hole. No. I'll give you ones to graph with holes and ones to graph with vertical asymptotes, but you won't be doing both of them combined.
so how come if
So, okay, so the hole's at 2, so x equals 2. So on your graph, this is where x equals 2 right there. Right, x equals 2 here. So we have to go up and find the graph. So we go up and we go, okay, well, here's where that intersects the line. So you're just going to draw a hole right there. Does that make sense? Okay.